Today we're doing critical paths. We first need to work out, a critical path. So we need to determine what a critical activity is, and that's any task that, if delayed, will also delay the entire project, because we're talking about projects being completed on time. So if we delay something that relies, any activity that we rely on, and that pushes our project further, takes longer to do, then we've got a critical activity there. So here the edges show the minimum time to complete each activity. Could be in anything, could be days, it could be minutes, it could be seconds, it could be weeks, it doesn't matter, but it's in a time frame. We must have a start and a finish, which we denote by a 0 there, and you'll see it as we're doing the diagram. We've got an earliest starting time, which we say as EST, that's the earliest time an activity can commence. We've got a latest starting time, which we'll denote as LST, it's the latest time an activity can start. If these two are equal, then this is a critical activity, and therefore that shows us our critical path. If they're different, then we have a float or a slack time, and we can work it out by doing LST, so the latest starting time minus the earliest starting time. Right, let's put all this into practice, because it's a little bit hard to go through it. It says, example 1, for this information, produce a diagram and determine the critical path. Give floats of any non-critical activity. So we've got to start with our little circle, and we can put our word start there as well. So I'll put our start. Now, we've got to be able to read this table. Activity A, it doesn't matter what the description is, but the predecessor means what comes before it, and there's none. So we can put the A there with an 8. Okay, and we're going to A. Then we can go down. B has nothing there as well, so we do the B, no predecessor, and that is B, and it has a duration of 6. We've got to be able to read it. Yeah. Now, for C, activity C, that follows after A. It says A is a predecessor of that, so activity C has to come straight after A, and that's C with, it has a duration of 1 day. Then we've got, the next one is D. D follows B, and that has a duration of 2. So we've got to make sure that things are following each other properly. Then we have E. E follows C. And then if we look at it, we'll write that in. So that's E with a 3. And then we have F. F has to come after C and D. So what we have to do, because C's right up the top and D's down the bottom, what we'll do is we'll drop this dotted line, which we call a dummy line, from C to D. Okay? And we put the arrow going from C to D. So now that we're saying they're both at the same thing, and we put a capital D for dummy, and a 1, because it's our first dummy, with a 0 on there. Big 0, little 1. Okay? So dummy, 0. And normally a little 1 there, which we've already got, and a 0. So it means it's the first dummy, and it has no activity, no days on there. We've got E and F coming in together, because if you have a look at activity G, it needs E and F to be finished at the same time. So that's why we have them coming in together. And then G goes for 2. And after G, we have H. So we've got H in there. And then we've got the finish right on the end of our circle. And H goes for 1 day. And then little circle with the finish. Okay, so we have to specify the start and the finish places as well. So there we go, we've just drawn our diagram. Now the whole point is to be able to do to work out our critical path. So we normally start with a 0.
So I'll just put the boxes in so that we can fill them out. On
each line. Now I like to do a triangle and a square. The difference, some people like to do 2 squares. So we'll do the 2 squares in here. But if I was to explain it any other time, I would put the triangle in. One means the EST, so the earliest start time. The other one means the latest start time. Okay? So, put a 0 there, and we'll put another box here on the B as well, because this helps us work out the B and 0 there. So let's go along A. A, there's only one way to get to there, so that's an 8 in there. It takes us 8 days to get to that spot there. Then if we continue along that line along the C, we've already got 8 days done. C takes 1 more day, so that's 9 there. We're going to leave it there along that branch for the moment, and we'll explain why in a minute. So going along the B branch, we've started at 0, then B takes 6 days, so far to this point it's taken us 6 days. D takes another 2, so we've got 6 and 2, that makes 8 days. Okay, but if we look at that branch coming down the dummy, that has 9 days already. So 8 days coming along one way, 9 coming along the other way. We put the highest number, so we put the 9 in there as well. Then to get to this point here, which is where E and F meet, we've got 9 already along this branch, plus the 3 from the E, that makes us 12, or we've got 9 and 1 along this branch, that makes it 10. We put the highest number, so we put 12. One way to get to this next part, so add another 2 gives us 14, add another 1 gives us 15. So our project will take 15 days to complete. That's what we've just worked out. Now we've got to start at the finish and work towards the start, and this time if we've got more than one number, we put the lowest number in it. So let's start at 15 here. So now 15 there. One way to go backwards to this next point, which is take off a day, 14. 2 days to go back to the next point, take off 2, we've got 12. We'll go down to the F. From 12, we take off 1 day, that gives us 11. So we've got 11 days there. 11 days. To get to this point up here with this, where the C is, we've got 2 ways. From the 11 that we just wrote, going backwards, it's 0 we're taking off, so that's 11, or the 12, taking off the 3, gives us the 9. So we put the 9 days. And on the top of the box, I'm just going to write E, because that's coming from the E, so we don't get confused which way that came from. Continuing along that path, 9 take away 1 gives us the 8 days, and 8 take away 8 gives us 0. So I'll finish off the bottom section. We're at 11 here. Take away 2 gives us 9. Take away 6 gives us the 3. Okay, so now we're able to work out our critical path. The critical path, remember, the boxes have to be the same. So it's along A, then along C, then along the E, the G, and the H. So we'll write our critical path.
I'll just highlight it.
Yeah, good to shade it in so you can have a C. So there we all are. And critical path, we'll just put capital C, capital P for critical path. And we'll go, it's A to C, sorry, to E, to G, and to H. And then it says, give floats of any non-critical activity. Well, the non-critical activity is B and D. We always look at it. So B, there is a difference of 3. So we've got 3 there. And D, there is a difference of, looks like 3 there. So we better put 3. And F, there is a difference of 2. Okay, so, and we just do them by subtracting the 2. Next example. Given this information and diagram, find the critical path and give the floats of non-critical activities. Form a table showing EST and LST for each activity. Sometimes it's easier to form the table so you can see the difference straight away. But let's go from the start. This time we'll do it the other way, just a box, and then we'll do the triangle for coming back. So 0 in the box here, and 0 from the next branch on the B branch, 0. Then to get to A, we've got 6. So we've got 6 there. Oh, sorry, we better start that one again because we forgot to include this branch here. So to get to B is 9. 9 and the dummy is 9, or along the A was a 6. We better write the 9 in there. Remember, it's the highest number. We'll go along this branch down here, the D. 9 and 7, that gives us 16. 9 and 7 gives us 16. And to get to this next one, we've got the 16 and the 10, 26, or the 9 and the 8, which is 17. So we write the 26. And we'll put that it came along E, just so we know that it came along E. And then 26 and 12 gives us the 38. So 38 days to complete this project. Now we'll put the triangle in. This is going backwards. So we start at the 38. Take away the 12, and we've got, of course, the 26. We better go down along the E first. 26, take away the 10, gives us the 16. Now to get to this next one. 16 take away 7 gives us 9, or 26 take away 8. Of course, we might as well just put the 9 in there, and that's coming from the D one, so we'll write the D. So 9 and coming from the D, because coming from the D we will have 18, so don't worry about that one. Going down the dummy, so 9 take away 0 is still 9, and 9 take away 9 is 0 there, along the branch B. We better do the next one. 9 take away the 6 gives us 3, so we can work out everything. Critical path, starting at the start, remember we go where it's even, so it's along the B, up the dummy activity, down the D, up the E, and the F. So that's our critical path. B, D, to E, to F. Floats of the activity. Okay, so we didn't include A. A has a difference of 3. We didn't include the C. Now C, remember, we had 18. So 18 take away 9 is a difference of 9. And I believe they're the only two from memory yet that I can see. So that's it on that one there. We haven't done the table. We won't worry about the table. That's pretty easy. You're just writing them in, so you've got it. Project crashing. If we shorten some project time for activities, then we're speeding up the project. This is called crashing. And this, in turn, this gives us a new critical path. So example 3 says, for example 2, we change activity B to 5 days and C to 4 days. Then we get this one here. Okay, so we do get a new critical path, and we have to do it all. So
no, I think they should be able to do this.
Yeah, we'll
have a go at do that. But
we will tell you the critical path. So you just get your names, your things right. Critical path is from A to D, then to E, and then to F. And we will also tell you it takes 35 days to do this project.
So have a go at doing this question, but trying to get 35 days for crashing the projects, and see how you go with that.
Alright, that's 24C for you.